When I was thinking how to deploy this model, one of the first places I thought of was the NVIDIA container registry. They have a nice catalog and they have actually different models for life sciences, and OpenFold3 is there. You just need to generate your API key and then you will be able to pull this image from their registry. Now, that being said, I'm going to show you how I do that because I thought it was very interesting and I loved some of the other services. A company they recently acquired called Brew. But please, if you're following this, don't do this part hands-on, because while I was doing it, I actually realized that most likely the NIMs, as you can see here, that it says NVIDIA AI Enterprise, and it clearly says it includes the NIMs. And then a bit later on in this license, it explains essentially that you need an NVIDIA Enterprise AI license after the 90 days free trial, which is consistent. If you go back and we click here to the model card, it's actually pretty cool because you can experience it here, very similar to what we are building. They have a couple examples and they even show you how would you run it on the shell, which would be the commands, how would you run it on Python. And if you click on deploy, here they are redirecting you to their free trial of NVIDIA AI Enterprise. And this is exactly what I was going to tell you. You need to generate an API key, then you can pull the container and you can then just start running it. And here they even show you a sample script. I think I'm going to demo that, but we are going to use another solution. And very important, if you go here to the docs, you will see the prerequisites in terms of the drivers you need. You will also need the NVIDIA toolkit. This will become relevant later on when we try to run it on an EC2. You need later on an EC2 instance that has Docker, the drivers, and the NVIDIA toolkit. In terms of the GPU, it also tells you a bit later that it requires, one second, it requires one of these. So I'm going to demo it, for instance, in this one, but you could choose any and also be careful because you need at least 64 gigs of CPU RAM and at least 8 cores and at least 48 gigabytes of GPU memory. So at the beginning, I just went ahead and tried to deploy it and I was running into lots of errors. And then I had to come back here and realize, oh, actually, it's all very well documented. So let's give it a shot. So recently, NVIDIA acquired this company, which I saw once the company defining themselves as the missing pro tier in Google Colab, which I think it's such a good sentence because it brings a very intuitive idea of what this company is about. But I do think that the best way to show you is to try it out. Let's click on the Get Started and log in into my account real quick. All right, so I'm logged in into my account. I have uploaded some credit and I can now create a new GPU instance. As I was saying before, we need L40. L40 will be supported. And then we need at least 48 gigabytes of GPU memory, 8 cores, and at least 64 of CPU memory, and at least 80 of disk space. So taking all of that into consideration, we can choose the cheapest one. Note that this one is no stop and start. So it means it will run continuously until you delete it. So I prefer to pay a bit more and have more flexibility. We have sufficient disk space. And here you can play with the different modes. This one is good enough for us. It comes with Python, CUDA, Docker, and Jupyter Lab. Let's deploy. The instance is starting and you can monitor the process here. I will stop the recording and show you the results. It has been a couple minutes and my VM is finally ready. It has set up the Python virtual environment with Python 3.12 and that it has downloaded a bunch of libraries, including Jupyter Lab, and it completed successfully. If we go back to access, this is how we would access it from our terminal. and you can choose your OS. I would like to go into the Jupyter Lab. Let's click. By the way, it's interesting that you could share this with someone else. Just FYI. Yeah, so we are in, and I'm now going to go here to terminal, and I'm going to follow the instructions. This one, I pasted my API key, and now we are successfully logged in. I have exported the key, and I can now run it. The first time it's going to take a while because it needs to download the image locally, and it's a big image, so that takes some time. And when it does, it will run on port 8000. So that means if we go back to Jupyter Lab, we can send predictions to a local endpoint that will be running on port 8000. And we have super nice instructions here showing us how. Here you can see we are running localhost port 8000, and then it follows this convention. Here we have a protein sequence, the alignment, and the output will be in PDB format. This is not that different from the original open source projects. If we go to examples, inference inputs, we are going to do this, the ubiquity one, and the molecule type is a protein. It has one chain, chain A, and here it's passing the sequence. This is taking a while. I'm gonna stop the recording. All right, we were downloading the Docker image, and this took a while, but we are finally done. Like, a newer image has been downloaded, and as you can see from the logs, it's using PyTorch. We are loading the weights of the model, and we are almost ready to run inference. Perfect. So now the endpoint is up. So we'll run this cell. Note here how it got a new prediction. I think also what's interesting is if we look as to my, you can see how the model is being loaded into the GPU, and the response should be here, output.json. Requested the outputs, structures with scores. Yeah, here are the different atoms and the coordinates. And here we have the different scores. I'm going to download this file locally. I would say I'm going to stop the recording here. And we are going to repeat this process. But instead of using Brew, we are going to use AWS EC2 instance to run the model. And this will complete the backend tutorial. Very important, don't forget to switch it off. I'm not deleting it, even though you're paying a bit for the permanent volume. And the reason why I'm not deleting it is because I want to look a bit more into the BioNIM framework. So NVIDIA has something called the NIM framework, and the BioNIM is the life science version of it. And they have a very nice user guide. We look now at the NIMs, right? The NVIDIA Inference Microservices. I want us maybe later to look at the framework in general and maybe do one of these get started tutorials. We'll see. Tutorials, maybe this one. Yeah, maybe one of those. We'll see how we do. But so for now, I'm just stopping it and not deleting it. And you might do the same. Or you might just skip this part entirely and do the EC2 only. I'm logged in into the EC2 page. And I have here an EC2 instance running that's hosting the OpenFold3 model. Couple things I want to show you. First, if we click on the instance ID, we can see here the instance type. Can we get more details? Here it tells you which kind of NVIDIA GPU it's using. And here it tells you the exact specs. I'm using G5 12X large. So it has 4 GPUs. That's the memory of the GPU. And that's the number of virtual CPUs, and that's the memory. And because of what I believe are the license limitations of NIMs, we'll be running it from the actual projects. What I did was to create the virtual environment, install OpenFold3 as a Python package, install K-Align too, for the MSA step. And to run predictions, you just need to follow this command here. What I also did, and I'm going to show you, is I changed it a teeny tiny bit so that I can leverage the 4 CPUs that my instance has. And I did that by creating a runner.yaml file. I can show you in the actual instance. Before I do that, here you have the predict command. I was mentioning it, and I'm using one of the examples that are in the GitHub project. I'll show you which one. And here you can pass extra arguments. It says it also here. If you scroll up a bit, you can see all the arguments you can pass. So I'm passing the runner.yaml, not to be able to leverage the multiple GPUs, but I'm doing also things like the output format. So I'm changing it PDB. By default, it uses CIF. And I'm changing it to the PDB format because I have the feeling it will be easier to visualize. And then when I was running some of the examples, I was running into some memory issues. I'm using the low mem mode. I ran this prediction and the results are here, so I can show you what's in that folder. You can see the different PDB models, for instance, the confidence score, it's producing different samples. I will download that locally. And as a next step, now that I got the backend more or less working, acknowledging I have to do a lot of tweaks, but let's try to visualize the results in my lovable front end, because I'm sure there will be some libraries similar to PDB Viewer to visualize these files. This is a free website. I can import a file, apply, and you can see the 3D structure of the protein. I think it's enough of this stage. I want to show you a couple of more things of the EC2 instance, which is the cut runner.yaml file that I created with the changes I mentioned. And then here, you can see here the 4 GPUs we were mentioning before, and obviously right now nothing is running. What else is interesting? Maybe it's interesting to see how I launch the instance. At the beginning, I started with either this Amazon Linux or Ubuntu, but this was a lot of work because I had to install Docker, I had to install the toolkit, the drivers. Then I thought, come on, like definitely somebody must have solved that, which is indeed the case. And here in the marketplace, you have this NVIDIA GPU optimized AMI, and it's an image that already comes with pre-installed GPU driver, Docker, and NVIDIA toolkit. It makes the entire process much more seamless. So select that one. And it doesn't cost any extra money. If you see it here in pricing, the instance I chose was this one. The price with and without the software is the same. I do want to mention one more thing, which is that when I was getting started, I realized that this command here is wrong. Trying to be a good citizen of the open source community, what I did is I opened a pull request half an hour ago, fixing the query. Let's see if that gets merged.